Hello everyone, welcome to your physics class of class 7th. I hope you all will be fine. Students, in our previous video, we discussed uniform motion, non-uniform motion and average speed. Okay, these three topics we discussed in our previous video and I told you to read yourself. Now today in this video we will start mass and weight. Now what is mass? As you have already learned that mass is the amount of matter contained in a body. Okay, in previous class also we have discussed this mass. So mass of a body is a quantity of matter contained in it. The mass of a body is constant and it does not change with change in position of the body. Means mass of a body means the amount of matter that is contained in this body remains same. Okay, at different at different positions. Okay, therefore the mass of a body is constant and does not change with change in position of the body. It is represented by symbol m, small m or capital M, and the SI unit of mass is kilogram. The smaller unit of mass is gram. We can write it as g and kilogram as small k and g and gram as small g. And we know that the relation between gram and kilogram is 1 kilogram is equals to 1000 gram, or we can say that 1 gram is equals to 1 upon 1000 part of a kilogram. Okay, 1 gram is equals to 1 upon 1000 kilogram, or 1 kilogram is equals to 1000 gram. Okay, the mass of a body is expressed by its magnitude. Okay, mass of a body is expressed by its magnitude only, and it is measured with the help of a beam balance. Okay, mass is measured with the help of a beam balance and it is expressed only by its magnitude, that is numbers and units. Suppose the mass of a body is 5 kilogram, so it is represented by number, that is magnitude and unit. Okay, now weight. The weight of a body is the force with which earth attracts the body, that is the weight of a body is a force of gravity on it. Means the weight of a body is defined as the force with which earth attracts the body towards itself. Okay, the weight of a body is not constant but it changes from place to place. Unlike mass, as it remains same at different positions, weight changes from place to place. It is represented by the symbol W, capital W, and SI unit of weight is Newton, and symbol for Newton is capital N. 1 Newton is nearly the force of attraction of Earth on a mass of 0.1 kg. The other unit of weight is kilogram force, that is kgf. Okay, it is written as kgf, where 1 kgf is equals to 10 Newton. This is the relationship between 1 kilogram force and Newton. The weight of a body is measured by a spring balance. As mass is measured with the help of a beam balance, weight is measured with the help of a spring balance. It is expressed by stating both magnitude and direction. In mass is expressed as by only magnitude, but weight is expressed in both magnitude and direction. The direction of weight is always vertically downwards because Earth attracts an object with the force of gravity towards itself, that is weight therefore acts vertically downwards. If force of gravity on mass of 1 kilogram at a place is g Newton and weight W of mass m kilogram at that place is given as W is equals to mg, where W is weight, m is a mass and g is gravity, where g is equals to 10 Newton kilogram inverse. Note, mass and weight are not the same. Mass is the amount of matter that is contained in a body, whereas weight is a force with that earth applies on an object, okay, with which earth attracts an object towards itself, that is known as weight. And mass is a matter contained in a body, so they both are different. Second, kilogram is a unit of mass, whereas kgf is a unit of weight. Okay, for example, a body of mass 5 kilogram will have a weight 5 kgf, or about 50 newton. Do you know? In a spring balance used to measure the weight of an object, the object is suspended at one end. In a spring balance, object is suspended at one end and one end is fixed. The force of gravity on the object elongates the spring, and when force of gravity acts on this object, this spring gets elongate. Okay, this spring elongates. This increase in length of this spring, and due to the elongation, the increase in length of this spring is directly proportional to the weight suspended. Okay, and so it is calibrated to directly measure weight in kgf. Now third one is, the mass of a body can never be zero, but weight of a body is zero at the center of earth and in an artificial satellite. Mass of a body can never be zero, but weight can be zero. Means weight is the force with which earth attracts a body towards itself. If at any place gravity is zero, and then therefore the weight at that place is also zero. Okay, and it is at the center of the earth and in an artificial satellite. Now, effect of change in place on mass and weight. The mass of a body remains constant everywhere on the surface of earth or on any other heavenly body. Means mass remains constant at all places, but the weight of a body changes from place to place because it depends on the force of attraction of earth on the body, which differs from place to place. The force of attraction of earth changes from place to place, therefore weight changes from place to place. For example, the mass of a body is same on earth's surface on moon surface, but the weight of the body on moon surface is 1/6 of the weight of the body on earth's surface. Why? Because the force of attraction of moon on that body is 1/6 of the force of attraction exerted by the earth. And because the force of attraction of moon is 1/6 of the force of the attraction that is exerted by the earth, therefore the weight of the body on moon surface is 1/6 of the weight of the body on the earth's surface. Now, difference between mass and weight. First difference is, it is a quantity of matter contained in a body. Weight is the force with which earth attracts the body. Second, the SI unit of mass is kilogram, whereas SI unit of weight is Newton, and another unit is kilogram force, where 1 kgf is equals to 10 Newton. Mass is constant for a body and it does not change by changing the place of the body, and weight is not constant for a body, it changes from place to place. Mass is measured with the help of a beam balance, whereas weight is measured by a spring balance. Okay, so these are the differences between mass and weight. So with this, our lesson number 2, explanation part of lesson number 2 is completed here. You have to read this lesson. Okay, so it will be more clear to you, and question answers and exercises we will complete in our next video. Okay, thank you.